December 16th, 1944. The Ardennes Forest, Belgium. Obersturmführer Heinrich Müller pressed his eye to the periscope of his Panzer IV, watching the morning mist cling to the frozen pine branches like the breath of ghosts. Operation Wacht am Rhein, Hitler's final gamble in the West, had begun with such promise just hours before. The surprise had been complete, the American lines shattered, and Müller's 12th SS Panzer Division was driving deep into enemy territory, racing toward the Meuse River through what the Americans called the Battle of the Bulge. But now, something was wrong, terribly, inexplicably wrong. Through his headphones, Müller could hear nothing but static, broken fragments of German voices, and the occasional burst of what sounded like clear, coordinated American transmissions cutting through the chaos with crystalline precision. His radio operator, Unterscharführer Weber, was frantically adjusting dials and checking connections, but their Fug 5 radio system continued to deliver only fragments. Panzer, under attack. Request. Bzd. Cannot reach. Bzd. American. Tanks. Bzz. Meanwhile, through the static, American voices emerged with disturbing clarity, speaking in calm, professional tones about grid coordinates, ammunition counts, and tactical dispositions with a precision that made Müller's blood run cold. What Heinrich Müller could not have known, as he watched his carefully planned offensive dissolve into chaos around him, was that he was witnessing the most decisive technological advantage of the Second World War, not superior armor or bigger guns, but something far more subtle and infinitely more devastating: the systematic domination of the electromagnetic spectrum by American radio technology. This wasn't just about communication equipment. This was about the manifestation of American industrial supremacy in its most sophisticated form, the deployment of electronic warfare capabilities that rendered German tactical doctrine obsolete before the first shot was fired. What Müller was experiencing wasn't communication breakdown. It was the sound of American technological dominance, transmitted at 300 MHz and received with crystalline clarity by every Sherman tank within a 50-mile radius. The revelation that would have shattered German confidence, had they fully understood it, was that every M4 Sherman tank rolling through the Ardennes possessed radio equipment more advanced than anything in the German inventory. While German panzer crews struggled with primitive, unreliable communication systems that functioned poorly under ideal conditions and failed entirely under combat stress, American tankers operated the most sophisticated mobile radio network ever deployed in warfare, a system so advanced that it had already rendered traditional tank versus tank combat doctrine obsolete. The numbers alone reveal a technological gap that German intelligence never fully grasped. The standard SCR-508 radio system installed in Sherman tanks operated with a power output of 20 watts, a frequency range of 20 to 27.9 MHz, and a reliable communication range of 15 miles under combat conditions, 25 miles under optimal conditions. The system included both voice and continuous wave telegraph capabilities, frequency modulation to reduce interference, and crystal-controlled frequency stability that maintained clear communication even during high-speed maneuvers and heavy vibration. By contrast, the Fug 5 radio system equipping most German tanks in December 1944 generated only 10 watts of power, operated in a narrower frequency range of 23.4 to 25 MHz, and provided reliable communication over distances of barely 3 miles under ideal conditions, often much less in combat. The German system lacked frequency modulation, relied on amplitude modulation that was easily disrupted by atmospheric interference, and used vacuum tubes so fragile that vibration from tank movement frequently knocked transmissions offline entirely. But the technological disparity extended far beyond basic specifications into realms of industrial sophistication that German engineers found impossible to match. American radio systems incorporated automatic frequency control, temperature compensation, shock-mounted components, and modular design that allowed rapid field replacement of damaged parts. German radios were hand-assembled, individually tuned, and so delicate that replacement parts often required factory recalibration before installation. The contrast represented not just superior American engineering but American manufacturing capability operating at scales that German industry could never approach. By December 1944, the United States had produced over 523,000 SCR-508 radio systems, more advanced radio equipment than Germany had manufactured in total across all military applications since the war began. Each Sherman tank represented not just armored fighting capability, but a mobile node in the most sophisticated communication network ever deployed by military forces, a network that rendered German tactical coordination primitive by comparison. The psychological impact on German tank crews was immediate and devastating, though many never understood what they were experiencing. Obergefreiter Klaus Zimmermann, gunner in a Panzer IV supporting Müller's advance, later wrote in his diary, "The Americans speak to each other constantly, clearly, as if they are sitting in the same room rather than scattered across kilometers of battlefield. We strain to hear fragments of our own commands through static and interference, while they coordinate attacks with the casual efficiency of a telephone conversation. How do they achieve such clear communication?" Klaus's question touched the heart of American technological superiority in ways that German tactical doctrine had never anticipated. The clarity, he observed, wasn't accidental. It was the result of systematic American investment in communication technology that had begun years before the war and accelerated into the most comprehensive radio development program in military history. The SCR-508 system installed in Sherman tanks wasn't just advanced radio equipment, it was the product of American electronics industry operating at full capacity. The system required precision manufacturing of quartz crystals for frequency control, vacuum tubes engineered to withstand combat vibration, resistors and capacitors produced to tolerances measured in percentages, rather than the crude approximations that characterized German electronics production. The crystal oscillators alone represented American technological superiority that German industry found impossible to match. Each SCR-508 radio system contained multiple precision-cut quartz crystals, each one ground and polished to resonant frequencies, accurate within 0.01%. The manufacturing process required industrial equipment that existed nowhere in German-controlled territory, diamond cutting tools, precision grinding machines, and temperature-controlled curing ovens that operated continuously for days to achieve the required frequency stability. By 1944, American crystal production totaled over 50 million units annually, more quartz crystals than German industry had produced since radio development began. The casual availability of precision crystals for military radio systems demonstrated American industrial depth that German planners had never anticipated. While German radio operators struggled with frequency drift, atmospheric interference, and temperature variations that rendered their equipment unreliable, American tankers enjoyed crystal-stabilized communications that maintained perfect clarity regardless of environmental conditions. But perhaps most devastating to German tactical effectiveness was the American development of frequency modulation, a technology that German engineers understood theoretically but could never manufacture at scale. FM transmission, as implemented in the SCR-508 system, virtually eliminated atmospheric interference, reduced background noise to negligible levels, and provided communication clarity that German amplitude modulation systems could never approach. The mathematics of frequency modulation revealed American technological sophistication that German forces encountered but never understood. FM transmission required precise control of carrier wave deviation, modulation indices calculated to optimize signal-to-noise ratios, and receiver circuits capable of detecting frequency variations measured in kilohertz, rather than the crude amplitude changes that characterized German radio technology. Hauptmann Friedrich Weber, commanding a company of Panzer IVs during the Ardennes offensive, observed the practical impact of American FM superiority. Enemy tank coordination appears almost telepathic. They maneuver as a single organism, responding to threats and opportunities with reaction times that suggest instant communication. Our own coordination suffers constant delays, misunderstandings, and communication failures that leave individual tanks isolated and vulnerable. Friedrich's tactical observations reflected technological realities that German doctrine had never anticipated. American tank platoons operated as coordinated units because their radio systems enabled instant, clear communication between all vehicles. Tank commanders could coordinate maneuvers, share targeting information, request support, and adapt to changing tactical situations in real time because their radios functioned with telephone-like clarity and reliability. German tank formations, by contrast, operated as collections of individual vehicles connected by unreliable communication links that functioned intermittently under ideal conditions and failed entirely when most needed. German tank commanders often resorted to visual signals, messenger runners, or simple assumption about their comrades' intentions because their radio systems could not be trusted for tactical coordination. The industrial capacity required to produce advanced radio systems at scale revealed American manufacturing superiority that transcended simple quantity and entered the realm of technological revolution. The SCR-508 radio system contained over 200 precision components, vacuum tubes, resistors, capacitors, inductors, switches, connectors, and mechanical assemblies that required manufacturing tolerances impossible to achieve with German production methods. Each vacuum tube alone required industrial processes that Germany could not replicate. American electron tube production involved precision glass-blowing equipment, high vacuum pumping systems, cathode coating materials produced through chemical processes unavailable to German industry, and quality control testing that eliminated defective units before installation. The result was vacuum tubes with operational lifespans measured in thousands of hours rather than the dozens of hours typical of German wartime production. The resistance networks that controlled radio frequency response and signal processing required carbon composition resistors manufactured to tolerances of plus or minus 5% precision that German industry reserved for the most critical military applications. American radio systems used such precision components as standard, mass-produced items available in sufficient quantities to equip over 500,000 radio systems without straining production capacity. But the most sophisticated aspect of American radio superiority was invisible to German observation: the systematic training program that ensured effective utilization of advanced equipment. American tank radio operators received weeks of specialized training in radio theory, maintenance procedures, antenna positioning, frequency selection, and communication protocols that optimized system performance under combat conditions. The training program represented American institutional commitment to technological advantage that extended far beyond equipment production into human capital development. American radio operators understood the theoretical principles underlying their equipment, could perform field maintenance and repair, could adapt to changing tactical situations by adjusting frequency, power output, and antenna configuration, and could integrate radio communication seamlessly into tank operations. German tank radio operators, by contrast, received minimal training in equipment operation, little understanding of underlying technical principles, and no capability for field maintenance beyond replacing obviously defective components. German radio training focused on basic operation rather than optimization, producing operators who could use their equipment under ideal conditions, but had no capability to adapt to the technical challenges of combat operations. The contrast became visible during extended combat operations, when equipment reliability and operator competence determined the difference between coordinated tactical effectiveness and communication breakdown. American radio systems maintained performance throughout lengthy engagements because operators understood how to compensate for changing conditions, adjust equipment settings to optimize performance, and perform preventive maintenance that kept systems operational. German radio systems degraded rapidly during combat operations because operators lacked the technical knowledge to maintain optimal performance, could not adapt to changing environmental conditions, and had no capability to perform the maintenance procedures necessary to sustain equipment reliability under combat stress. The impact on tactical effectiveness was measurable and devastating. American tank formations maintained coordinated operations throughout engagements lasting hours or days because their radio systems continued to function reliably. German tank formations gradually lost coordination. As individual radios failed, operators became confused by equipment malfunctions, and communication networks collapsed under the accumulated stress of combat operations. Staff Sergeant Michael O'Brien, commanding an M4 Sherman during the Ardennes counteroffensive, observed German tactical coordination through American eyes. The Krauts start every engagement with good tactical discipline, but their coordination falls apart as the fighting continues. Individual panzers get isolated, stop responding to commands, and start making tactical decisions that don't mesh with their overall plan. It's like watching a football team lose its ability to call plays. O'Brien's observation reflected tactical realities that German commanders experienced but never fully understood. The gradual breakdown of German tactical coordination wasn't the result of poor training or defective doctrine. It was the inevitable consequence of communication systems that could not sustain reliable operation under combat conditions. The technological gap extended beyond basic radio equipment into the realm of electronic warfare capabilities that German forces never recognized. American radio systems incorporated features designed to counter enemy interference, intercept enemy communications, and maintain operational security in electronic warfare environments that German technology could not create. The SCR-508 system included multiple frequency channels that allowed American units to shift communication networks when enemy jamming threatened primary frequencies. Frequency, agility, the ability to change operating frequencies rapidly and coordinate frequency changes across multiple units provided American forces with electronic warfare capabilities that German technology could not match or counter. German radio systems, operating on fixed frequencies with limited channel selection, were vulnerable to any form of electronic interference and had no capability to adapt to enemy electronic warfare measures. American units could effectively jam German radio networks simply by transmitting noise on the limited frequencies available to German equipment, while German forces had no capability to disrupt American communications operating across multiple frequency bands. The electronic warfare implications were profound and largely invisible to German tactical observation. American units could coordinate complex maneuvers while simultaneously disrupting German communication networks, creating tactical situations where American forces enjoyed perfect coordination, while German forces operated in electronic isolation. The Industrial Revolution in electronics that enabled American radio superiority was invisible to German intelligence, but represented the most significant technological development of the war. American electronics production in 1944 included 1.2 billion vacuum tubes, 15 billion resistors, 8 billion capacitors, and 200 million quartz crystals, electronic components manufactured in quantities that German industry had never achieved across all product categories combined. The scale of American electronics production enabled not just superior radio equipment, but entire electronic systems that transformed the nature of warfare. American tanks incorporated not just advanced radios but electronic fire control systems, navigation equipment, and maintenance diagnostic tools that represented systematic application of electronics technology to military operations. German tanks, by contrast, remained essentially mechanical systems with minimal electronic content. The contrast wasn't just technological, it was conceptual. American military doctrine assumed electronic coordination, navigation, and fire control as standard capabilities, while German doctrine treated electronics as auxiliary equipment that might or might not function when needed. The conceptual gap became visible during tank versus tank engagements, where American crews operated with electronic assistance for target acquisition, range calculation, and ammunition selection, while German crews relied on manual procedures that had remained unchanged since World War I. American gunners used electronic range-finding equipment that calculated target distance automatically, while German gunners estimated ranges visually and adjusted fire through trial and error. The engagement at Celles, Belgium, on December 24 to 25, 1944, demonstrated American radio superiority in its most devastating form. The German 2nd Panzer Division, spearheading the deepest penetration of the Ardennes offensive, found itself surrounded by American forces that coordinated their encirclement through radio communications of unprecedented clarity and effectiveness. Oberst Meinrad von Laukert, commanding the 2nd Panzer Division, later described the engagement in testimony that revealed German incomprehension of American technological capabilities. The enemy seemed to anticipate our every movement, to respond to our tactical adjustments before we had completed them, to coordinate attacks from multiple directions with timing that suggested a single controlling intelligence. Our own communication with division elements became increasingly fragmented as the engagement progressed, until individual companies were operating without coordination or mutual support. Von Laukert's testimony reflected tactical realities that German doctrine had never anticipated. American tank formations operating as electronically coordinated networks rather than collections of individual vehicles. The single controlling intelligence that he observed was actually the decentralized coordination enabled by reliable radio communications that allowed multiple tank commanders to share information, coordinate maneuvers, and adapt to changing tactical situations in real time. The encirclement of the 2nd Panzer Division was achieved not through superior numbers or firepower, but through superior coordination enabled by advanced radio technology. American tank commanders could communicate with artillery units, air support, supply columns, and higher headquarters simultaneously, creating integrated combined arms operations that overwhelmed German forces operating with primitive communication capabilities. The artillery coordination alone demonstrated American radio superiority in devastating detail. American tank commanders could request artillery support using precise grid coordinates, adjust fire through real-time communication with forward observers, and coordinate artillery strikes with tank movements to achieve maximum tactical effect. The entire process, from initial request to shells impacting on target, required less than 3 minutes when executed by radio-equipped American forces. German tank commanders, lacking reliable radio communication with artillery units, often could not request fire support at all, could not provide accurate target information when communication was possible, and could not coordinate artillery strikes with their own tactical movements. German artillery support, when available, operated independently of tank operations, and often proved as dangerous to German forces as to American targets. The contrast was measurable in tactical effectiveness. American tank, artillery coordination, achieved target destruction rates of over 80% with initial fire missions, while German artillery operating without radio coordination achieved target destruction rates below 20%, with most rounds falling on empty terrain because of outdated target information and communication delays. But perhaps the most devastating aspect of American radio superiority was its impact on logistical coordination. Sherman tanks operated with radio communication to supply columns, maintenance units, and fuel trucks that enabled continuous logistical support during extended operations. Tank commanders could report ammunition expenditure, fuel consumption, and maintenance requirements in real time, allowing supply units to anticipate needs and position resources for maximum efficiency. German tank operations, lacking reliable radio communication with logistical units, operated with pre-positioned supplies that could not adapt to changing tactical situations. German tank commanders often found themselves without ammunition or fuel during critical engagements because logistical units had no current information about tactical developments or supply requirements. The impact was cumulative and decisive. American tank formations maintained operational capability throughout extended engagements because their radio systems enabled adaptive logistical support, while German tank formations gradually lost effectiveness as they exhausted pre-positioned supplies and could not communicate their requirements to logistical units. Major General Ernest Harman, commanding the U.S. 2nd Armored Division during the Ardennes counteroffensive, observed the German logistical breakdown through American tactical intelligence. German tank units start engagements with good supply status, but lose effectiveness rapidly as they consume ammunition and fuel without resupply. Their logistical coordination appears to rely on pre-planned schedules rather than real-time communication, leaving individual units stranded when tactical developments differ from original plans. Harman's observation reflected operational realities that German logistics officers experienced daily: the inability to adapt supply operations to changing tactical requirements because of communication limitations that rendered real-time coordination impossible. German logistical doctrine assumed predictable tactical developments that would proceed according to predetermined schedules, an assumption that proved fatally flawed when confronted with American tactical flexibility enabled by superior radio communications. The psychological impact of American radio superiority extended beyond tactical effectiveness into the realm of morale and confidence. German tank crews could observe American coordination capabilities during combat, noting the clarity and precision of enemy communications while struggling with their own communication failures. The contrast was demoralizing and frightening, suggesting American technological capabilities that German forces could not match or counter. Unterscharführer Weber, the radio operator whose struggle with static and interference had frustrated Obersturmführer Müller during the opening hours of the Ardennes offensive, wrote in his diary, "The Americans talk to each other as clearly as if they were in the same room. They coordinate attacks, share information, and adapt to our movements with communication quality that seems impossible under combat conditions. Meanwhile, we strain to hear fragments of orders through static and interference that makes coordination a matter of guesswork rather than precise control." Weber's observations reflected technological realities that extended far beyond individual radio equipment into systematic American advantages in training, maintenance, logistics, and industrial support. American radio superiority wasn't just better equipment, it was better utilization of technology, better support systems, and better integration of communications into overall tactical doctrine. The maintenance requirements alone revealed American industrial depth that German forces never understood. SCR 508 radio systems required regular replacement of vacuum tubes, calibration of frequency circuits, cleaning of electrical contacts, and adjustment of mechanical components to maintain optimal performance. American tank units received continuous supply of replacement parts, test equipment for field maintenance, and technical specialists, trained to perform complex repairs under combat conditions. German tank units, by contrast, operated with minimal spare parts for radio equipment, no test equipment for field diagnosis of communication problems, and no technical specialists capable of performing repairs more complex than replacing obviously defective components. German radio equipment degraded steadily during combat operations and could not be restored to original performance levels without factory overhaul. The cumulative effect was systematic degradation of German communication capabilities throughout extended campaigns, while American radio performance remained consistently high because of superior maintenance support and more reliable equipment design. The training differential represented perhaps the most significant aspect of American radio superiority. American tank crews received integrated training that treated radio communication as essential to all tactical operations. Tank commanders learned to coordinate movements through radio communication, gunners learned to share target information electronically, and drivers learned to respond to radio-transmitted navigation instructions. The training program produced tank crews who operated as electronic teams rather than collections of individuals sharing physical space. American tank operations assumed constant radio communication and could not function effectively without it, producing tactical doctrine that maximized the advantages of superior communication technology. German tank training, by contrast, treated radio communication as auxiliary to visual and mechanical coordination. German crews learned to operate effectively without radio communication and treated electronic coordination as helpful but not essential. The training philosophy produced tactical doctrine that could function with primitive communication systems, but could not exploit advanced radio capabilities even when available. The contrast became visible during tank versus tank engagements, where American crews operated with integrated electronic coordination, while German crews relied primarily on visual observation and mechanical signals. American tanks engaged targets identified by other crew members, maneuvered according to radio-transmitted instructions, and coordinated fire with other tanks through electronic communication. German tanks operated as individual fighting vehicles that happened to share common objectives rather than as electronically coordinated teams. German tactical coordination relied on visual signals, predetermined plans, and individual initiative rather than real-time electronic communication, producing tactical performance that was predictable, rigid, and vulnerable to disruption. The industrial implications of American radio superiority extended far beyond military applications into the civilian economy that supported military production. American electronics industry in 1944 represented the most advanced technological capability in human history, producing not just military radio equipment, but civilian broadcasting equipment, telephone systems, radar installations, and electronic control systems that had no equivalent in German industry. The civilian foundation for military electronics production was invisible to German intelligence, but represented American technological advantage that transcended simple military spending. American companies producing SCR 508 radio systems also manufactured civilian radio receivers, television equipment, and electronic components for automotive, aviation, and industrial applications. German electronics production, by contrast, was concentrated almost entirely in military applications, with minimal civilian market to support technological development or provide industrial capacity for military expansion. German radio technology remained primitive because German industry lacked the civilian demand that drove American technological advancement and manufacturing capability. The contrast was profound and structural. American radio superiority reflected the mature development of an electronics industry supported by consumer demand and competitive innovation, while German radio limitations reflected the underdevelopment of electronics technology in an economy focused primarily on mechanical engineering and heavy industry. The strategic implications of American radio superiority extended far beyond tactical battlefield effectiveness into operational and strategic warfare capabilities that German planning had never anticipated. American forces could coordinate complex operations across multiple theaters simultaneously because their communication systems enabled reliable coordination over continental distances. The radio network supporting American tank operations in Europe connected directly to communication systems, coordinating Pacific operations, strategic bombing campaigns, and logistics operations spanning multiple continents. American military communications represented a global electronic network that German technology could not match locally, much less on global scales. German military communications, by contrast, operated as isolated local networks with limited capability for coordination beyond immediate tactical requirements. German strategic coordination relied primarily on courier service, telegraph systems, and telephone networks that were vulnerable to interdiction and could not support the dynamic coordination that characterized American military operations. The difference became visible during simultaneous multi-theater operations, where American forces demonstrated coordination capabilities that suggested centralized planning and real-time adaptive control across global distances. German forces operated as geographically isolated commands that could not coordinate effectively with other theaters or adapt quickly to strategic developments in distant locations. The electronic warfare capabilities embedded in American radio systems represented technological advancement that German forces encountered but never understood. SCR 508 systems incorporated features designed to counter electronic interference, intercept enemy communications, and maintain operational security in contested electronic environments. American tank commanders could monitor German radio communications directly, obtaining real-time intelligence about enemy tactical intentions, supply status, and command decisions. The intelligence advantage was systematic and continuous, providing American forces with tactical omniscience that rendered German operational security meaningless. German forces, lacking comparable electronic warfare capabilities, operated in electronic isolation that prevented them from intercepting American communications or protecting their own transmissions from enemy monitoring. German tactical planning assumed communication security that did not exist, and tactical surprise that was impossible to achieve against electronically superior opponents. The intelligence implications were devastating. American forces operated with continuous real-time intelligence about German tactical intentions, while German forces operated with minimal intelligence about American capabilities or intentions. The asymmetry in information warfare rendered traditional tactical principles obsolete and created engagement conditions that favored American forces regardless of numerical or positional advantages. The revelation that would have broken German morale had they fully understood it came through the casual testimony of captured American tank crew members. Sergeant James Mitchell, captured during a reconnaissance mission in January 1945, described American radio capabilities in terms that German intelligence officers found impossible to believe. Every tank in the battalion can talk to every other tank instantly, clearly, over distances up to 25 miles, Mitchell explained during interrogation. We coordinate movements, share target information, request support, and adapt to changing situations in real time. Tank commanders can talk directly to artillery observers, air support, supply units, and higher headquarters using the same radio system. Communication quality is so good that talking to another tank 15 miles away is clearer than talking to someone across a noisy room. Mitchell's testimony revealed communication capabilities that German technology could not provide locally, much less at the scales and distances he described. German interrogation officers initially dismissed his statements as propaganda or exaggeration, but subsequent technical intelligence confirmed that American radio systems possessed the capabilities Mitchell had described. The confirmation came through captured equipment analysis that revealed the true sophistication of American radio technology. German electronic specialists examining captured SCR-508 systems discovered manufacturing quality, component precision, and design sophistication that exceeded German understanding of what was technically possible. Oberingenieur Hans Kollmann, one of Germany's leading radio engineers, examined captured American equipment and reported to German High Command. The American radio systems demonstrate manufacturing capability and design sophistication that we cannot match with current German industrial capacity. The precision of component manufacture, the sophistication of circuit design, and the reliability of system operation exceed our capabilities by margins we had not thought technically achievable. Kollmann's report represented the closest German technical intelligence came to understanding American radio superiority, but even his analysis failed to grasp the full implications of what he observed. The captured radio systems were not exceptional examples of American manufacturing capability. They were standard production units, representative of over 500,000 similar systems produced by American industry. The systematic nature of American radio superiority was invisible to German analysis because German engineers could not conceive of industrial systems capable of producing advanced technology at such massive scales. German technical thinking assumed that sophisticated equipment required individual craftsmanship and limited production quantities, making mass production of advanced radio systems theoretically impossible. American industrial methods that treated sophisticated radio equipment as mass-produced consumer goods transcended German understanding of manufacturing capability and represented technological revolution that German industry had never achieved. The casual availability of precision electronics for military applications demonstrated American industrial maturity that German planners had never anticipated or prepared to counter. The final revelation came through German analysis of battlefield tactics that consistently favored American forces regardless of numerical, positional, or situational advantages. German tactical analysts, searching for explanations of consistent American tactical superiority, gradually identified communication coordination as the decisive factor in American battlefield effectiveness. Oberst Wilhelm Stemmermann, analyzing German tank losses during the Rhineland campaign, reported to Army Group B headquarters, American tactical superiority appears to result primarily from coordination capabilities that enable their forces to operate as integrated systems rather than collections of individual units. This coordination is achieved through communication systems of unprecedented reliability and effectiveness. Our own forces, operating with primitive communication capabilities, cannot achieve comparable tactical integration and are consistently defeated by coordinated American operations. Stemmermann's analysis approached accurate understanding of American radio superiority, but failed to grasp the full scope of technological and industrial advantages that enabled such coordination. German tactical analysis focused on battlefield effectiveness without understanding the underlying technological and industrial foundations that made American coordination possible. The Industrial Revolution in electronics that supported American radio superiority was invisible to German intelligence, but represented the most significant technological development of the 20th century. American electronics production had transformed from experimental technology to mass manufacturing industry in less than 2 decades, creating industrial capacity that exceeded German imagination and enabling military capabilities that German doctrine had never anticipated. The transformation extended far beyond military applications into civilian technologies that supported military production, commercial broadcasting systems that developed mass production techniques for radio equipment, telephone systems that required precision electronic components, and automotive applications that created demand for reliable electronics under mechanical stress. German industry, lacking comparable civilian demand for electronics technology, never developed the manufacturing capability or technical expertise necessary to compete with American radio production. German radio technology remained laboratory curiosities and limited military applications that could not approach American scales of production or levels of sophistication. The contrast was decisive and permanent. American radio superiority reflected industrial maturity that German industry could not achieve during wartime, while German radio limitations reflected technological underdevelopment that could not be corrected through military spending or engineering effort alone. In the end, the story of German ignorance about American radio superiority reveals the most profound technological advantage of World War II. Not superior firepower or better armor, but the systematic domination of communication and coordination through advanced electronics technology. German tank crews never knew that every Sherman tank possessed radio equipment more sophisticated than anything in the German inventory, communication capabilities that enabled tactical coordination impossible with German technology, and electronic warfare advantages that rendered German operational security meaningless. The radio systems installed in Sherman tanks weren't just communication equipment, they were manifestations of American industrial supremacy in its most advanced form, demonstrations of technological capability that German forces encountered but never understood, weapons of coordination that defeated German tactical doctrine before the first shot was fired. German tank commanders like Heinrich Müller experienced American radio superiority as inexplicable tactical effectiveness, mysterious coordination capabilities, and communication clarity that seemed to violate the natural laws of radio propagation. They never understood that what they experienced was not supernatural coordination but superior technology, not tactical genius but electronic advantage, not mysterious capability, but systematic American investment in communication technology that had begun years before the war and reached maturity in time to render German tactical doctrine obsolete. The static and interference that plagued German radio communications while American voices cut through the electromagnetic spectrum with crystalline clarity was not accidental or temporary. It was the sound of technological revolution, the manifestation of industrial capability that exceeded German understanding, the electronic signature of American dominance in the most sophisticated warfare technology of the 20th century. The mathematics of coordination were loaded not in armor thickness or gun caliber, but in frequency modulation and crystal oscillators, in vacuum tube reliability and precision resistors, in the casual deployment of electronics technology that German industry could not produce at scale, and German doctrine had never anticipated. American victory was achieved not through superior tactics but through superior communication, not through better tanks but through better radios, not through mechanical advantage, but through electronic dominance that rendered German military capability obsolete before the war was decided. The revelation that German forces never fully grasped was that they were fighting an enemy who had already won the war in frequencies they could not hear, through coordination they could not achieve, using technology they could not understand, deployed at scales they had never imagined possible. The Sherman tank's greatest weapon was not its 75mm gun, but its SCR 508 radio system, the most advanced mobile communication technology ever deployed in warfare, and the decisive advantage that ensured American victory regardless of German tactical skill, strategic planning, or military courage.